Right, so moving on to question number 2. Again, I would say this question is also not hard, but this question is tricky at one point. So I will tell you which point is it. So X and Y are S block elements. So they have given these as S block elements. They react with water to form hydroxide. So actually they react with water. So these cannot be beryllium because they are not much reactive with water. The hydroxide of X is more basic than of Y. So this gives the idea that X should belong to group 1 and Y should belong to group 2. Okay. The hydroxide of X is used in the manufacture of baby soap. So I have mentioned this before in the discussion of soap production as well. So normally for baby soap, to make the softness, so we add potassium hydroxide. The hydroxide of Y is commonly used to identify the gas Ez, and that is one of the main gases responsible for global warming. So this is CO2. And the hydroxide Y, the hydroxide is calcium hydroxide. So you can see this is not like the normal typical question. This is very easy, not hard. Okay. And so according to this piece of information that they have given, automatically we can identify the element X as potassium. You can put either element symbol or write down the name. And this is calcium. Okay, so write the electronic configuration. So this becomes very simple now. You can write down the electronic configuration. It is not hard now. And moving on, write the color of the flame given by the salts of X and Y. So we know X is potassium, Y is calcium here. Okay. So X is going to give the lilac color and Y is going to give the brick red color. Okay. So this is going to be brick red. This is going to be brick red. Here, this is very important that I need to put here. Marks could be awarded for mentioning it as orange in color. So this is like a question because this is very simple, right? Because we always study about the flame test, flame colors of these S block elements and a few transition elements as well. So why they are accepting orange for here for the brick red is a little bit of concern. But in this particular year, they have also taken this one as a correct option. But generally, brick red is the correct answer. Okay. And then you have to like check what is actually happening when potassium and calcium, their periodicity is compared. Okay. So atomic size, so potassium, you know, group 1. So calcium is group 2. So, you know, group 1 higher than group 2. So basically X will be higher than Y here. Okay. And density, so when you are trying to get the density, so both are metals, so you check the strength of the metallic bonding. So calcium little more smaller and with a higher number of electrons to the metallic bonding electron C. So calcium will be more dense than potassium. You see how you compare the density? And when there is higher density, more rigidness, your melting point is also going to increase. So again, Y is greater than X. Then first ionization energy, so you know potassium is group 1, so there is only one outermost electron, NS1, but here it is NS2 is a stable configuration, so this one will have the lowest one. So again, it is y is greater than x. Okay, so I hope you understood this one. Atomic size and first ionization energy is very straightforward. Density and melting point, this basically depends upon the rigidness. So density you can compare with the size and the amount of electrons that is given to the C. So anyway, the number of electrons is one higher in calcium and the size is smaller. So there is a higher rigidness. So calcium density and melting points are higher. Okay, so this question is, you see, this question is not hard and it gives a basic idea. They have given all the basic information that you need to identify these two elements. Then simple question of electronic configuration and the flame test and some periodic properties. Okay, and identify Z. So what is Z here? So hydroxide of Y, which is calcium hydroxide, is used to identify the gas Z. So you know, normally we use calcium hydroxide to identify carbon dioxide, right? So this is the typical gas that is identified using calcium hydroxide. So this is CO2. Using balanced chemical equations only indicate how the hydroxide of Y could be used to identify Z. Indicate precipitate, if any, using and colors of precipitate solutions. Okay, so I will use the board here to explain the reaction. So basically we will have calcium hydroxide is our solid, and in fact it could be aqueous as well. So we send CO2 gas. So what is going to happen here? Initially we told that there is a white precipitate that is formed, and when you further add this carbon dioxide, it turns colorless. So initially this calcium and carbon dioxide will give you calcium carbonate solid, which is white precipitate. So there will be this precipitate, plus from hydroxide it forms water. This is one of the reaction that forms the white precipitate. And then you have this calcium carbonate solid, plus again more CO2 gas, and in the solution you have water, which gives you calcium bicarbonate at this point. HCO3 twice aqueous, which is colorless. Okay, so these two are the two main reactions that you need to write down there and indicate this one as white color precipitate. Okay. You see this reactant here is calcium carbonate, water. Additionally, you will have carbon dioxide here that gives your calcium bicarbonate. Okay, so I will share the screen again. So this is what you have to mention here, those two reactions that I have written on the board. And then I hope it is balanced. Calcium is one, carbon, oxygen, hydrogen. Yeah, everything is balanced here. So you don't need to even balance this one. Natural source of Y in which it is present as a carbonate is used as a raw material in the manufacture of a disinfectant. So why is calcium? And when it is present in the carbonate form, so CO3 2 minus. So what is the natural source of calcium in the... So can you tell what is it? What is the natural carbonate form of calcium? Yes, it is limestone. So it is limestone, which is very important raw material in many industries that we use. So what is the form when you have, for an example, calcium carbonate and this is limestone calcite. So if you have calcium carbonate and magnesium carbonate mixture, what is the natural source? That what is the name of this one? Do you remember the name of this one? Yeah, this is limestone. So what is the name that you normally give when you have a mixture of calcium carbonate and magnesium carbonate? Yes, it's called not slake lime. When you have calcium carbonate and magnesium carbonate as a natural source, okay? So when you have calcium carbonate as a natural source, we tell that as limestone. But when you have calcium carbonate and magnesium carbonate, this is typically called dolomite. Okay, don't forget these things. These are very important. When you have only magnesium carbonate, what is it? The natural source of magnesium carbonate. So what is the natural source of magnesium carbonate? No idea. So remember, don't forget these things, okay? So when you have magnesium carbonate, we normally tell this as magnesite. Magnesite. Okay? But don't confuse this with magnetite. Okay? You have iron two sources. One is hematite and magnetite. So hematite contains Fe2O3 and magnetite contains Fe2O3 and Fe3O4. So magnesite means it is of magnesium carbonate. This is not magnetite, this is magnesite. Anyway, we'll come to the question. So identify the natural resource. It is limestone. And identify the disinfectant. So basically the disinfectant is bleaching powder. So bleaching powder. Or either you can write down the formula as calcium OCl twice, because there should be OCl minus. This is one. Or you can also use a big formula if you know there is the idea here. When you have this one, you have like OCl, then hydroxide, and calcium chloride, and water. So this is the big formula of bleaching powder. There will be OCl, there will be hydroxide, and calcium chloride dot 2H2O. Okay, so this is the normal general formula of this calcium oxychloride, in fact, the bleaching powder. Write the steps in the manufacturing process of the disinfectant using the balanced chemicals equations only. So you cannot explain the things, you just need to write down the balanced equations. So I will, so they have to, you use limestone to make the disinfectant, which is our limestone. So basically there should be this reaction, calcium carbonate solid You heat up to get calcium oxide solid and carbon dioxide gas. So this should be one of the reactions. And the second reaction is you have calcium oxide and you add water. So you will have calcium hydroxide. Okay. And when you have calcium hydroxide, what you can do is you can send with chlorine gas. This is what normally we do to obtain this bleaching powder. So when you add chlorine gas, you will have calcium OCl twice and OH twice and calcium chloride dot 2H2O. Okay, so you have calcium OCl2 and calcium hydroxide. You can put calcium hydroxide. Don't put like within the same one. You can calcium OCl2, calcium hydroxide, and calcium chloride dot 2H2O. So there are 3 calciums. So I can put here 3. And in fact, here there are 2 chlorines. So 4 chlorines. So I can put 2 here. And I guess others are balanced. Calcium, oxygen 3, carbon 1, yeah. And calcium, oxygen 2, hydrogen 2, yes. So 3 calcium, 4 chlorines. And hydrogen is 4, 6, so 2 into 3, 6, yeah. Everything is balanced. Okay. So this will be calcium OCl2, calcium OH2, calcium chloride 2 dot 2H2O. So these questions becomes tricky because of this part. Okay, only because of this part. Because normally you don't remember these things. In fact, instead of using calcium OCl2, calcium hydroxide, calcium chloride dot 2H2O, you can end up writing calcium OCl2. But this is the complete picture. Okay, so try to understand the complete picture. So you have limestone, you heat to get calcium oxide, and then you get the hydroxide, just like lime, then you send Cl2 to get this bleaching powder. Okay. This is the point where this question becomes a little bit tricky, I would say. Otherwise, there is no point in this question. This question was very easy. This is one of the points that becomes tricky because if you don't know or if you don't remember the equation of making the bleaching powder, this becomes a little bit of a problem. Okay. Complete the reactions. So the part B, complete the reactions given below by selecting appropriate solution from the given list and writing in the box. So you have to write down in the box using the compounds that is given here. So here there are 6 boxes and 6 compounds that they have given. So we will go through it. White precipitate. So when you have barium chloride, so you mix with one of these white precipitate that dissolves in HCl to give a clear solution. So which gives you the idea when you mix this one with one of these, it gives you a white precipitate, but it dissolves in HCl. So we'll see what are the precipitates. So barium with this one will form sodium chloride and barium S2O3. So this is not a precipitate. And barium nitrate is not going to be a precipitate. AgCl is a precipitate that can form when you add these two. Okay. But when it will not dissolve in HCl, so then only in excess HCl or conc HCl. So then barium with sulfate, so it formed the barium sulfate, but it will be not dissolved in HCl. Okay, and barium with carbonate will form barium carbonate, which is a white precipitate. Yes. And it will dissolve in HCl. So up to now, this is okay. So barium chloride with barium chloride, no. Barium iodide is not a precipitate. So basically, our first box, we will have the ammonium carbonate here because all others cannot have this precipitate. In fact, according to this AgCl can be formed with this one. Barium sulfate can be formed this one. So these two are white precipitate, but the problem is it will not dissolve in HCl. If you remember your chemistry, I explained to you there are many precipitates that is not dissolved in acids. So these two are one of it. So when you have lead, a yellow precipitate that dissolves in hot water, so automatically yellow precipitate of lead, if you remember, it should be lead iodide, right, which is dissolved in hot water, and when you cool it, again it reappears. So this should be potassium iodide. AgNO3, a white precipitate that turns black on standing. Okay, so we discussed this one earlier in the previous case. You remember, if you have Ag, so it should be like Ag2S2O3, right? Which eventually forms Ag2S, which is our black precipitate. So there should be S2O3. So this could be sodium thiosulfate, Na2S2O3. So this could be this one. And K2SO3, white precipitate that dissolve in HCl. So it should be something that is going to connect with sulfite. So what could be this? AgSO3, no. K2SO3, K2SO4, no. And ammonium carbonate, and these two are already occupied. These three are already occupied. So the only possible thing is barium chloride, because it will form barium sulfide, which is dissolving in HCl. Okay. NaBr, pale yellow precipitate that dissolves completely in conch ammonia. So if you remember, AgCl, AgBr, and AgI. Okay. AgCl is dissolving in even in simplest dilute ammonia. AgBr in conch ammonia. AgI not in both. So it will not dissolve in any of these, either diluted or conch. So it should be AgBr form. So there should be some Ag compound. So it is AgNO3, which gives you AgBr, which is a yellow color precipitate. In fact, this is normally white color AgCl, little bit yellow and highly dark yellow. And barium nitrate, white precipitate that does not dissolve in diluted HCl. So it doesn't dissolve mean either it should be the compound of barium sulfate or AgCl. So there is no AgCl that can form from here. The only compound is K2SO4 that is remaining, because all other boxes are completed. So K2SO4, when you add K2SO4, this will form barium sulfate. So this is the difference of these two, barium sulfite and barium sulfate. Barium sulfate does not dissolve in acid. Even this does not dissolve in nitric acid as well. So this one will dissolve, okay? So this is not hard, okay? So you know the inorganic analysis part, this becomes straightforward. Write balanced chemical equation for the dissolutions of precipitate A, D, and E. What is A here? It's barium carbonate, yes. D is barium sulfite, and E is AgBr. So we will try to write down these things, okay? A is barium. So A is barium carbonate. This is A, D, and E. D is AgBr. D is, what is D? Barium sulfite. Yeah, this is barium sulfite. So you add HCl. So what is going to happen here? That is what they ask you. So you know, eventually when you add these two, there should be barium chloride that is formed, and carbonate is CO3 2 minus with H plus. So it should give carbon dioxide and water. And again, barium chloride, SO3 2 minus with H plus. So we have already seen this. These are the anions that give gases with water. So gases with acid. So this should be again SO2 and water. And finally, AgBr, this is not in acid. They are as in ammonia. So this should be ammonia. So you know this is going to form a complex. So silver amine complex plus Br minus here. Okay. So there will be two ammonia that is occupied and Br minus is there. You can balance all these. In fact, they are balanced up to a certain point. Yeah. So these are the three dissolution reactions. Okay. So barium carbonate with HCl and barium sulfide with HCl and silver bromide with ammonia. It will give a silver diamine complex. Which is a positive charge species and which is a colorless one here. So typically we study about this one in KSP, where this is a partially soluble salt. And when we try to add ammonia and see what is actually happening for its solubility, and some of it will be remain as this AgBr solid, and some of them will be as Ag plus and Br minus in the solution, and some will be as in the complex form when you add ammonia. So we try to discuss about its solubility in the presence of ammonia. This is the identification method, basically the dissolution of these precipitates. So this is done.